Good morning. I welcome you all for today's session, Ripple Counters. So far we discussed about registers, and in this session we are going to discuss about counters. So first, before going to Ripple counter, we should know what is a counter. So a counter is a device which stores the number of times or process which has occurred, often in relationship to a clock signal. For example, in up counter, a counter increases count for every rising edge of clock. Not only counting, a counter can flow the certain sequence based on our design like any random sequence like 0 or 1, 3, 2. It is not must that it has to count from 0, 1, 2, 3. It may be 0, 1, 3, 2. They can also be designed with the help of flip-flops. They are used as frequency devices where the frequency of given pulse waveform is divided. Counters are sequential circuit that count the number of pulses, can be either in binary code or BCD form. The main properties of a counter are timing, sequencing, counting, and counter works in two modes. One is up counter and another one is down counter. So these are the classifications of counter. Counters are broadly divided into two categories. One is asynchronous counter and another one is synchronous counter. We should know what is asynchronous counter. So this is asynchronous counter, the circuit diagram of asynchronous counter and the timing diagram of asynchronous counter. In asynchronous counter, we don't use universal clock. Only first flip-flop is driven by main clock, and the clock input of rest of the following flip-flops is driven by output previous flip-flops. Asynchronous counter, from the timing diagram, that Q0 is changing as soon as the rising of the pulse is encountered. Q1 is changing when rising edge of Q0 is there, because Q0 is like clock pulse for second flip-flop and so on. In this way, ripples are generated through Q0, Q1, Q2, Q3. Hence, it is also called ripple counter and serial counter. A ripple counter is a cascaded arrangement of flip-flops where the output of one flip-flop drives the clock input of the following flip-flops. Now coming to synchronous counter. Synchronous counters has one global clock with its input in of the flip-flop. So output changes in parallel. The one advantage of synchronous counter over asynchronous counter is it can operate at higher frequency than asynchronous counter, as it does not have cumulative delay because of same clock is given to each flip-flop. This is also known as parallel counter. So you can see the synchronous counter block diagram here. We have four flip-flops, that is JK flip-flop, and two AND gates which is connected, and the connections are as per the circuit. And also we have a clock pulse, clock signal. So we know the clock signal gives high and low signals. So if high means it counts like upwards and low means it counts from downwards. So this is the circuit diagram. Coming to ripple counter, it is a cascaded arrangement of flip-flops where the output of one flip-flop drives the clock input of the following flip-flops. The number of flip-flops in the cascaded arrangement depends upon the number of logic states that it goes through before it repeats the sequence of parameter known as the modulus of the counter. A n-bit ripple counter can count up to 2 power n states. It is also known as mod n counter. It is known as ripple counter because of the way the clock pulse ripples its way through the flip-flops. Next, ripple counter. The features of ripple counter. It is an asynchronous counter. Different flip-flops are used with a different clock pulse. All the flip-flops are used in toggle mode. Only one flip-flop is applied with an external clock pulse, and another flip-flop is clock obtained from the output of the previous flip-flop. The flip-flop applied with an external clock pulse acts as LSB in the counting sequence. So a counter may be an up counter that counts upwards, or can be a down counter that counts downwards. Can do both, that is count up as well as count downwards depending on the input. The sequence of counting usually gets repeated after a limit. When counting up for the n bit, the count sequence goes down from 000 to 001, etc. When counting down, the count sequence goes in opposite number 111, that is 111 to 110, etc. This is the block diagram of 3-bit triple counter using JK flip-flop. So your counter starts from 0 to 7 and counting like the outputs like the Q0, Q1 and Q3. So in the circuit shown in the above figure, your LSB will toggle for each clock pulse because JK flip-flop works in toggle mode when both J and K are applied 1 or high output. The following counter toggle when the previous one changes from 1 to 0. This is a 3-bit triple counter used in the circuit above, has 8 different states, each one of which represents a counter value. Similarly, a counter having n flip-flops can have a maximum of 2 to the power n states. The number of states that a counter owns is known as its mode, that is modular number. Hence, a 3-bit counter is a mode 8 counter. A mode n counter may also be described as a divide by n counter. This is because the most significant flip-flop triggers by the clock pulse. Thus, the above counter is an example for divide by 4 counter. So, this is a divide by 4 counter using JK flip-flop and the timing diagram of the JK flip-flop. Counters are used very frequently to divide clock frequencies and their uses mainly involved in digital clocks and in multiplexing. The widely known example of the counter is parallel to serial conversion logic. Advantages of ripple counter in digital logic can be easily designed by T flip-flop or D flip-flop, can be used in low-speed circuits and divide by n counters, used as truncated counters to design any mode number counters like mode 4 and mode 3. Disadvantages of ripple counter in digital logic, like extra flip-flops are needed to do resynchronization. To count the sequence of truncated counters, additional feedback logic is needed. Propagation delay of asynchronous counters is very large while counting the large number of bits. Counting errors may occur due to propagation delay for high clock frequencies. This is all about ripple counters. Thank you.